So we now want to look at bases for the null space of A and the column space of A. So starting here by thinking about the null space of A, we've actually already done this before. We did this back in section 4.2. So to find a set of vectors that spans the null space for some matrix A, we simply find the general solution of the homogeneous equation. So we find the general solution of matrix A multiplied by vector x equals the 0 vector. So to do this, we'll need to row reduce the augmented matrix A with the 0 vector and write our final solution in its parametric vector form. Or in other words, write the solution in terms of the free variables. So since the free variables act as weights, the spanning set is automatically linearly independent. So since the free variables act as weights here, the spanning set that results is automatically linearly independent. So then to establish a basis for the column space of a matrix A, we use the spanning set theorem along with the fact that the pivot columns of a matrix A form a basis for the column space of A. So to find a set of vectors that spans the column space of some matrix A, we simply reduce A to echelon form. We're then able to construct a basis for the spanning set by removing any redundant vectors. So to find a set of vectors that spans the column space of some matrix A, we want to reduce matrix A to echelon form. This then allows us to construct a basis for the spanning set by removing the redundant vectors. So in other words, the non-pivot columns. So let's go ahead now and take a look at some examples.